Hello, everybody. Welcome to the latest TWIS podcast broadcast. We're here to talk about science with you. So this is the pre-show part where I tell you that this is a live show. So we're doing this live, our first show of the year. There will be errors because I'm on cold medication and my brain doesn't work anymore. So Blair's basically going to do the show by herself while I'm a hype girl. But yes, the show will be edited for the podcast version. And so if you want the nice edited thing, head over to wherever you find podcasts and make sure you subscribe to TWIS. But we're back. We're ready to go. Are you ready for a show? Do I need to say anything else? I don't need
That's
to.
everything.
Right? That's everything. Yeah. My lights are like really changing everything here. I'm in a place, I guess. Okay. Woot woot. Let's go cold meds. All right. We're starting this show in. I like this one better. I'm a little bigger. Starting this show in 3, 2. This is TWIS. This Week in Science, episode number 1042, recorded on Wednesday, January 7th, 2026. Sanitize your timeline with science. Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with health, age, and shark eyeballs. But first, disclaimer, disclaimer, disclaimer. Should old lessons be forgot and never brought to mind? Should what we've learned be ignored in favor of Old Lang Syne? For Old Lang Syne, my dear, for Old Lang Syne. We'll record it all for posterity, the days of Old Lang Syne. Society has come so far, reached so many dreams, but we've also lost so many dear since the days of Old Lang Syne. We'll raise a cup of kindness yet in the name of Old Lang Syne. This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you, Blair, and everyone else out there. Welcome to another episode of This Week in Science, our first episode for 2026. I do want to apologize as we get into our amazing show for all those missed shows in December. All of our fun shows we haven't done yet. We didn't do because I was sick for like all of the month. I'm still a little bit woozy, but I'm coming back. I've never been so tired and brain dead. I mean, just not functional in my life. So I apologize for not communicating, not being here, not getting anything done. I was incapable of doing it. I missed all the holidays too, so that was a bummer. Yeah. Anyway, we're here. And I have hopes for health and prosperity for all of us for 2026 and for a great year of science discussions.
That sounds great.
Does that sound good?
To it. Yeah.
If you're still in, Blair, let's keep talking about
Well,
science.
I'm here, aren't I? I know. I made it through a pretty challenging December as well, so I'm back.
We're back, baby. Here we go. It's time for all the fun stuff, all the science for this week. On this week's show, I have stories about ancient humans, Alzheimer's disease treatments, and a mouse brain bacterial boost. What did you bring for the Animal Corner, Blair?
I brought some really old sharks and some really dead invertebrates, fossils.
Like really, really dead.
Yeah, like so dead, like millions of years ago dead. Very excited to talk about it.
Awesome. I mean, if it's not, strange mating habits of invertebrates, it's the dead ones that we love.
Mhm.
Okay. No. As we jump into the show, I just want to remind you that by subscribing to the TWIS podcast broadcast on all of the places that we're found or the places that you like to find your science discussions, you help maintain us and pop us up into the algorithm. So if you're not subscribed, if you haven't hit like yet, if you haven't shared, please do so. But remember, we are here as many Wednesdays at 8 p.m. Pacific time as possible on YouTube, Facebook, and Twitch, and that we are on most of the podcast platforms out there. And you can find information about the show at twis.org. Time for the science. You ready?
Ready?
Okay, good. I'm like,
I was
wait, she's
muted.
not.
I'm sorry. Like I'm not ready because I'm muted. No, hit me up with some science, please. I have needed it.
We're a little out of practice. Oh my gosh. After 25 years, sometimes it's like hard to come back from a few weeks on break. Okay.
25 years. Don't say that out loud.
Oh, this is starting. Yeah. It's been a while. I said it. Okie dokie. Starting off the show, we're going to start with, eating the frog first. We are going to talk about the elephant in the room straight off. This week, RFK Jr. took some pretty unilateral decisions and made changes within the CDC to the the recommended vaccine schedule, as well as the food pyramid. That's the newest one as of
Whoa.
today.
I
Yeah.
didn't know about that one.
That just happened today. I just read about it about 45 minutes ago. So this is new. He was saying they were going to do it, but hadn't done it yet. So this is exciting. Aren't we excited about these great changes?
Yeah, I'm sure. Really, really good.
No, not so great. So as an article in JAMA Internal Medicine is reporting that from the CDC themselves, a report of illnesses, medical visits, hospitalizations, and deaths in the United States from October 2022 to September 2024 as a result of COVID-19 illnesses. They found that, we're nowhere near the 2021 height of over 400,000 people dead in the United States from COVID-19, but annually they saw around 100,000 deaths in the United States from COVID-19, which is more than we see on an average flu season. It's similar to some of the heights of the bad flu seasons that we see in the United States, but it is definitely still prevalent and dangerous, specifically and mostly to older adults, 65 and over. And it's recommended in this that vaccination for those people who are more at risk for COVID-19 and who can be vaccinated, that is something that will protect people, especially in places like nursing homes or convalescent hospitals where you have high populations of vulnerable people who are around each other. And currently, the vaccination rates, even in these vulnerable locations and vulnerable populations, have dropped significantly. So even in these places that are supposedly taking care of our, the older family members that we have in our populations, they are not doing the care to ensure that individuals are being properly vaccinated against COVID-19 in a way that would help prevent illness and death from the disease. So anyway, that was one of the recommendations that came out this week at the same time that RFK Jr. Has changed the recommended vaccination schedule from the CDC so that it no longer recommends a number all the vaccinations to be taken at the same time, and suggests that vaccinations should occur over a much longer window of time, that the hepatitis B vaccine, which has saved hundreds of thousands of lives by being an infant vaccination at birth, that they're recommending that vaccination does not occur until 12 years of age. They are also now recommending and putting money toward an unblinded, not balanced, or not controlled trial in Africa, in one of the impoverished nations of Africa that isn't allowed to travel to the United States. That's one of the but the country is going to, they are have a serious hepatitis B problem, and the trial that is being financed by the United States will not be done in a way that is actually for the best care and long-term health of the infant population and the adult population in the country. They will be following infants for 5 years after vaccination, but we know that hepatitis B does not actually cause problems that really impact life expectancy until later in life. So they should be doing a trial that those people from birth to like 35, 40 years of age, and they are not doing that. Meanwhile, the rest of the vaccine recommendation schedule that is now being has been released is nothing related to, well, I'm saying nothing, there's some things in there, but it is rolling back decades of evidence and experience in public health from experts in the public health sector, and it isn't based in evidence, which
So
is concerning.
I once again ask the question: is this dumb or malicious? Is this somebody thinking they know better than the experts and they really think they're helping, but they are just super uneducated? Or are they trying to get people sick?
Why not both?
Right. So then why?
Oh my gosh. Well, Disney, you just said the same thing that I said.
Why do we want to get children sick? What is the motivation for rolling back vaccines?
What is the motivation? And for one of the big questions that we do not know at this point in time is if the vaccination schedule and vaccines have been removed from the schedule, if those are not recommended by the CDC and by the government, are they going to be funded by health insurance? This is something we do not know yet. So the question also is, if people actually do want to get vaccinated for certain diseases, and according to the old vaccination schedule, is that going to be will it be continued to be honored within the medical insurance establishment? I honestly don't know. Your question is important because this is something that I don't understand. I understand that the arguments against vaccines, I understand where they come from, and I understand the fear that parents have for their children and the stories of vaccine injury. It's frightening, but it's bigger than one person, one family. This is living in a society. And I believe this is it is the argument between complete individual determination versus a social cohesion, where there is actually a public commons, a public good that people work toward. I think they are inherently different philosophical positions. I don't believe everybody who is against vaccines is, it's not just one or the other. There's definitely, there are multiple ways of looking at the world. But it's really concerning. especially so hepatitis, the HPV vaccine, which was approved, within the time of this show, within the last 20 years, it has already been shown to have an impact on not just female cancer, but male cancers. And if females and males are vaccinated, that cancers later in life are less likely and in those individuals. And over again, the HPV vaccine is shown to be effective and successful. However, it is one that is not going to be recommended. So this is, these sweeping changes. It's they're changes. Then people keep talking about, oh, it's making us like Denmark. And there's an article in The Conversation that discusses the fact that Denmark is a country of 6 million people with universal health care and a national registry that tracks every patient. The United States has 330 million people, 27 million uninsured, and a system where millions move between providers, not to mention states and different regions that are not necessarily recorded or tracked over time. And a different aspect that is brought up, and one that many parents and people talk about, is the number of adjuvants, or the number of vaccine components within the vaccines. And it's one of the reasons that people argue for spacing out vaccines. And it's not necessary. If you're going to take your child to all the visits and get the vaccines done, great, go do it. One of the reasons that they were spaced more closely together is because our bodies and our immune systems can handle it. And over the years, many of our vaccines have gotten more efficient. So vaccines like the pertussis vaccine started out with 3,300 adjuvants within it, and now it is in the range of like 30 or 60. So here it is. So in the 1980s, the pertussis vaccine contained roughly 3,000 antigens. That's the word I was looking for. Apologies there. Today's entire schedule contains fewer than 160 antigens. And so, what we're looking at is the improvement in medicine, a reduction in the number of the antigens that are included in many of these vaccines because they've gotten more efficient and effective at targeting the places where they're supposed to. So the vaccine schedule now is safer than it was in the 80s. But now we're going back to something, that's different. And it's been great progress. And people don't talk about it enough. And I honestly did not know this until I read this article in The Conversation. And I'm like, why is this not wider news? We should be talking about this, because the vaccine burden, right? The immune system burden that people are talking about, it's not that much of a burden anymore. And the vaccines that we have saved thousands and thousands and thousands of lives. So anyway, that's the big, eat the frog moment, what's happened this week. And then I mentioned the food pyramid, which I think is the wildest thing. They've put like steak and potatoes and cheese at the top of the food pyramid. There's
for the cow lobby and the dairy lobby.
And there's really like all the good foods and good oils, like never mind saturated fats, who cares anymore? Never mind all of the evidence related to the benefits of things like the Mediterranean diet. Whole grains, fruits, vegetables, those are not prioritized. And a different article that I read suggested that it was implemented as a kind of like an ideal, as like an ideation of like the ideal diet that an American should be eating, right? What is, so if we go back to 1935 or 1960 or whatever, 50, whatever.
I mean, that's what all this is about turning the clock back. You and I getting back in the kitchen. That's what this is about.
I love the kitchen. I do. And sometimes I'm barefoot, sometimes I'm in socks. I love the kitchen. I love cooking, but no, I got things to do and I have a mind, right?
That's what they want. They want strict class lines, usually related to also race and other yucky things like that. And then they also want they want to have their whiskey at their steak lunch where they go with their like other men in suits. That's what they want. They just want to live inside Mad Men. That's what they want to do.
See, I think
They all
that's
just want to be Don Draper, but they never will be.
No, you don't get to be Don Draper. There's only one man who was Don Draper. That's it. And he was an avatar, right? And not a good person, but it was fascinating. Yeah. Long Koenig. Pros never go barefoot in the kitchen. I know. Lab safety. Don't drop a knife on it. Yeah.
No open-toed shoes. Go back
No
and change.
I know. Oh. Well, anyway, this was the big bad. And I just wanted to
Wow.
get it out of the way off the top because what I think is important is that there is evidence behind the previous CDC vaccine recommendation schedule. We can obviously still make our choices about whether or not we space them out or what we do, but vaccines are effective. They have been effective for decades in improving the health and wellness of this country so that we could achieve all the freaking things that we've achieved, even with the bad diet of steak and cheese.
But also, like, okay, so if you're gonna halfway vaccinate everybody, okay, like only people who either can afford it or know to ask for it or actually go through the extra appointments to get the vaccines, okay. Then you mix them all up in the daycare or in the kindergarten or whatever, right?
Right.
You don't have full protection, and you have lots and lots of opportunities for adaptive radiation within these diseases.
Yeah.
Just so much opportunity for superbugs. This is like making it worse.
I mean, we've been watching this happen even before the new schedule came out. Measles has been making a comeback in the United States because people have been avoiding the MMR vaccine. There's no reason for measles to be making a comeback. And we as people are kind of allowing that to happen. And I'm wondering, as they get rid of the Department of Education, as they privatize all the schools and is it just going to turn into, there's some schools that are going to be schools where you can go with vaccinated people, and there's going to be other schools where you go with unvaccinated people, and you have to make a choice about whether you're not going to pay for that one or you can afford that one. And oh, never mind if you can't afford the school for the kids who are vaccinated. Right.
So then you're just creating class lines again.
Yeah.
And you're creating modern day segregation is essentially what you're doing, which again is what some of these people want.
Hello. Yes. Welcome to the past. So let's look at the future with some more fun science. Yeah. Want to move forward? Not talk about vaccines anymore?
Yeah. I mean, I just want to say one last thing, which is, as I mentioned to my sweet husband, Brian, this morning.
Oh, I love the way that you said that, though.
This is not the dystopian future that I was promised. Like, you grow up reading these young adult fictions, and you grow up watching movies where you have to vanquish this, like, totalitarian overlord, but
in
there's
a video game
cars and there's robots that do more than fold laundry or drop dishes, and I just didn't expect like systematic intentional degradation of the good things that government does, and then just insanity on my phone every day of news, and also Elon Musk's AI bot getting into just the most disgusting behavior. I don't understand that like a chat bot is doing the things that I don't understand this dystopian future, and I don't accept it.
And that is the thing. We all do not have to just accept the spoon-fed dystopia. We make choices. There are different platforms to use for social media. There are different companies to buy things from. There are different I'm really curious if we can get away from the profit at all costs model and just have businesses again where people provide cool services that solve problems and make a profit so that they work, but just aren't evil. Like, can we? Because there's so much in education, medicine, in media. Like, if you're doing it for good, there's so much there. So I'm just wondering, are we going to end up with like these parallel systems, right? Where you have the different groups of people doing different things like across from each other.
Yeah, I don't know. It's a mess. It's just all a mess. Can we get it together? Like, I would just love it if we could just scale back a little bit on this downward slide into nonsense. We'll see.
Yeah.
That's
Nonsense don't make sense.
Crossed for 2026.
Optimism is low. We gotta like those movies where they're like, bring back Christmas spirit. Like now, bring back optimism for the future. Come on, everybody, let's sing a song together, and we'll see the optimism meter rise.
Well, Disney says, "Welcome to Costco. I love you." I swear I saw a headline that said that Costco was going to start building apartments last week. I don't know if it's real or not, but there you go.
Solve homelessness. Let's do it.
All right. Well, let's should we talk about some fossils?
Yes, let's talk about fossils.
Great. Ammonites. I love ammonites. They're so cool. Ammonites are these beautiful fossils that look like nautiluses. They're related, not nautiloids. They're related to the nautilus, but they curve the opposite way from a nautilus. So
wait.
Yeah.
Explain that. Hold on.
Okay.
What?
So,
but they're just a spirally thing. So if they go the
good. I appreciate this this tangent. This is super fun. So
what? I didn't know this.
I'm gonna find a picture of an ammonite versus.
Well, I got ammonites here. So here, so we've got ammonites here. We've got
yes. So that's an ammonite, and their body comes out of the shell in the bottom there, and then it has to do with the inside, the way that the chambers are created in the inside. And there's none of those chambers. I was not prepared to give this lecture.
This is something brand new for me. I'm so excited.
Yes. So ammonites have complex chambers within their shell that look very different from nautilus chambers. I'm gonna have to come back to this because I don't want to be incorrect, but you can tell just by looking at the curvature of the shell if it is an ammonite or a nautilus, because their body structure is different. They are related, they are similar. It's not a direct lineage from one to the other. So
wait, no? Like really? But it's similar.
Similar, not the same.
Oh, so right now I've got the ammonite up.
Yes.
So we've got the segmented interior chambers, and you've got the actual organism kind of hanging out at the end with its like stuff out the back end that it uses for feeding and propulsion and all that kind of stuff. Right? Okay. And then we go to the nautiloids, and you still have segmentation on the inside. So like there's still chambers.
Yes, but the body plan is very
Mm.
different. Where's one of the diagram? I want a diagram of like a cross section of a nautilus. We're getting way off track here.
I don't care. This is awesome. Okay, this is the interesting stuff. I mean, it's still the animal goes out the back end.
Yes,
doesn't
it
right?
certainly does. But their body structure is very different, and so because it's different enough, the understanding, at least the last time I studied nautiloids, it's been a hot minute, 20 years, but
All right.
but that's why they've been determined as being separate branches of the cephalopod, like family tree. And I'm gonna have to look and find the exact language of how they're different. So yes, so if you look there, the chambers of the nautilus, I really don't want to get this wrong. They butt right up against the body of the animal.
Oh, okay.
And the body does not go into the shell chambers at all. It is fully segmented. But I believe the ammonite.
So is it like it grows its shell and it's like do, and it is always kind of getting bigger and growing out of
Yes.
itself?
Yeah.
And the ammonite is probably more, this is how my body's buoyant. Like, and it can go all the way through it.
Yeah. So
Okay. That's interesting. Okay.
Okay. So hold on.
We'll get to it if you want now, but I think this is fascinating.
So the sphincule, siphuncle. There we go. I got there.
What is the word?
The siphuncle, the tube that runs through the shell that helps control buoyancy. In ammonites, it hugs the outer edge. It is ventral to the coil. In nautiloids, it runs through the middle like a backbone.
Huh.
So the cross section is fundamentally different.
Mhm.
And then also in ammonites, the walls, which are called septa, are convex. They have like a wiggle and a curve. But in nautiloids, they curve the other way. They're concave.
Whoa.
So those are the things that I remember.
This is interesting. Okay, I always wondered. I was like, when did we get from ammonite to nautilus? And I always, like forever, I've just been like, oh, nautilus is basically an ammonite, but modern.
Mhm.
So this is fascinating. Thank you.
Yes. And so they share a common ancestor, but nautiluses did not come from ammonites. So that was, God, I did a very bad job explaining that. Anyway.
Brian Burwell says, so an ammonite has the shell on its back and the nautilus has the shell on its belly. Ish?
No. Not exactly. They both come out the bottom of the tube. It's not like the nautilus curves up the top.
They're not under, under, over.
Yeah.
It's that buoyant part is interesting.
So I only said that to talk about what an ammonite is, because a lot of people don't know what they are. So if you see this old like fossil and you're like, oh, it's a nautilus, it's probably an ammonite. You can tell because they have the concave chambers, and they have the gap along the edge instead of down the middle, and also they usually have a lot more twists in them, but they're really pretty. They also usually have these like ripples or edge, or kind of like ruffles have ridges along the edges of the outside of the shell. Anyway, all that to say, they are a very common fossil to be found because it's a hard body plan. So it's easy to fossilize. So that's check one. Check two, up until recently, it was assumed that they all were wiped out at the KT mass extinction, which this once again tells you how long it's been since I have been in formal studies. I didn't know it wasn't called the KT boundary anymore. It is now called the KPG Cretaceous Paleogene boundary.
When did that happen?
I don't know. As far as I'm
What?
concerned, today. I was like,
All right.
what's
New
the
nomenclature. All right.
KPG? So I don't know. I don't know when it switched over, and I'm gonna go in like this crazy deep dive at some point to figure out when the heck this happened. But it's now
Okay.
called the KPG boundary, and that's like learning how to walk again. I don't know if I'm ever gonna be able to say that. Like, I don't. Oh my goodness. But anyway, so they've retermed the KT boundary, KT mass extinction. Okay. Anyway, the assumption was that they were amongst the approximately 75% of all species on Earth that were wiped out at the time of this asteroid that hit the planet at 66 million years ago. However, this week, research was released that showed that they may have been around much longer than that. This is from the Polish Academy of Sciences. They found ammonite fossils at Stevensklint in Denmark, of course. This 15-kilometer long coastal cliff. It has a very clear layer in the rock that represents the KPG boundary. And so thanks to relative dating, you can figure some things out. You can figure out that is the KPG boundary. When fossils are found in a specific layer, then you know that they're either from that time or older. So something can move up but not down, basically, in the fossil layer. And so when it moves up, they'll call that a zombie fossil. It is eroded out of ancient sediments and redeposited in a younger layer of rock. But since something doesn't go down, if you find it at a certain line, it's that or older. And so they found ammonite fossils above the boundary line, which they were like, oh, they could be older, or they could be above the boundary. So that could mean that they were from after the mass extinction. And so if that's true, and they survived into the Danian period, which is the earliest part of the Paleogene, then they survived the mass extinction event. So then, to figure that out, they performed a microfasces analysis, I'm not sure, which uses high-powered microscopes to study sedimentary structures. And they looked at the makeup of the sediment inside the fossil shells, and then they compared that to the surrounding rocks. And they found that the mud inside the shells had sponge spicules, which are the little spikes on the animal, the sponge, which is typical in that period, the Danian limestone. And then there were no bryozoans, which are common in Cretaceous. They're not found in Danian limestone at all. So that means that most likely these ammonites were living and swimming in the post-extinction sea during that time. And so that means that they survived past the mass extinction, but still had their own extinction event because we don't have ammonites now. So the question is, what caused the extinction of ammonites? Because again, they're everywhere. Like, it's so easy to find these fossils. So like,
I love them. They're like,
you can keep looking.
Sandstone, marble. You're like,
Yeah.
oh, ammonite. I love them.
Yeah, so you have to, like, you could date every single ammonite that you find in every little gift shop, and you could kind of create a tableau of when were all these ammonites around. And then, there's also the question of what is the sediment like in these different periods? Was it just easier to collect ammonite fossils from before this extinction event versus after? Is it a function of the sediment? Is it a function of where they lived? Did they all move somewhere else? Was there, a drought? Was there a change in water conditions? Did they scoot somewhere where we haven't looked? And so there's more to be found here to figure out how long they did live, like when their final mass extinction event was. Was it like a whimper, or was it a boom that they went out with? And then what got them in the end? I don't know.
And there's an interesting question from Fada in the chat saying, asking, what did ammonites eat? So was there something in
Yeah.
what they ate that allowed them to exist for a longer period of time and eventually go extinct or be outcompeted by other similar organisms?
Yeah, I mean, they're essentially filter feeders in the water column, just like
Oh,
nautiluses are. So they mostly eat plankton or other small plants and animals in the water column. So um, it's hard to imagine a time period where there are animals on Earth where there's not some sort of planktonic food source. So
yeah.
I would wager there's something for them to eat no matter what. I think it's a question of like, did the oxygen content change in the water? Did temperatures change? Did turbidity change? Did they get a bunch of mud in their mouth with their plankton and so they couldn't get enough nutrients? So I feel like there's something else environmentally going on, or they just slowly died out because they were outcompeted. That is another option. It doesn't have to be a big dramatic exit.
I think the timing that they're suggesting in this paper is interesting, that it was 68,000 years after the impact, which, that's tens of thousands of years, which is
Mhm.
a significant amount of time. And, we're looking at our, having Neanderthals go extinct 50 or 60, 70, 80,000 years ago, right? So species can come up or fade away in that amount of time. There can be significant changes to ecosystems, to climate, to like, can you imagine how things must have changed after the impact over 68,000 years? Like immediately after the fires, the cloudy skies, like all that, like how long that impact affected so much stuff.
Mhm.
The Earth was constantly adapting and changing and evolving, and so yeah, fascinating.
Yeah.
Where'd they
So next
go?
time
I
you
mean,
see one of those ammonites in a little souvenir shop, just think you could hold the key to a new discovery.
oh, I love that. Right, old stuff, new discoveries. This is important, man. History's important. I have more history.
Yeah.
I want to move to early hominins. Let's talk about stuff Justin would normally talk about.
Hmm.
I miss Justin. But anyway, this is a story that I think he would have brought to the show. Evidence that was published this week, open access in Nature. Researchers have reported on fossils they discovered back in 2008, 2009 in an area of Morocco, the Grot Hominids Thomas Quarry 1 THIGH in Casablanca, Morocco. And this site, they have used the magnetosphere, so the shifting of our planet's magnetosphere, so its poles and the shifting of iron magnetic compounds in the layers of the Earth. So like you were talking about being able to look at those boundary layers, they are able to very, very accurately date this site to around 773,000 years ago. They're similar in age to a different discovery in Atapuerca, Spain, that's dated between about 1 million years and 770,000 years for a potential ancestor or ancestral population of hominids. This is one of the big questions of where did actual hominids evolve? So we know the hominid lineage from way, way, way back to modern day. We have the out of Africa knowledge, right? Life started, human life got its start. We go back to Australopithecus. There we go. Brain's working. We go way, way back to those very ancient hominid life forms in Africa. We know we now have multiple different species that evolved in different places across Africa, moved out of Africa into the Eurasian continent. We know we have Neanderthals, Denisovans, others that were also relatives of Homo sapien, modern humans. And so this study has evidence that suggests that the Homo sapien lineage didn't probably get its real start in Eurasia, that we did probably begin on the African continent. Potentially, this is one spot in Morocco, and it's exciting because it is a period of time where they have not found any fossils. There's like from about 400, 500,000 years ago to 1,000,000 years ago on the African continent, there's just a blank spot. And so this is one of the first pieces of evidence. There are several jaw bones, a thigh bone, many bones that they're looking at. They have not actually determined that, these were, Homo antecessor, which is the species that they are calling the fossils that were found in Spain. They're not, it's like Homo antecessor, which is like the human precursor, right? human ancestor. They're not actually saying that these bones are that same species, but they are, because they're morphologically different. However, there are all sorts of morphological things that they look at that they go, oh, they're very similar to later Homo sapiens and archaic hominins. So the evidence that they have discovered is very exciting because this, for the first time, gives pre-human bones on the African continent that suggest a lineage that is also in a location that could have been on that out of Africa path. Yeah.
And why is the idea that this is the, I don't know, it almost makes it sound like the narrative is supposed to be that this is the sole ancestor, like that this is like the whole out of Africa idea is that all humans started in Africa.
So this is not where they're going. I mean,
Okay.
but this is one of the big questions because they haven't actually found Homo-like evidence on the African continent. So there's all these other species, but not actually like the close ancestors of Homo sapiens. So the common ancestor between Neanderthal and Denisovan is that there. And they're not saying that this is what they're suggesting. And they're even the scientists themselves are saying that like this has just been a gap in time. So they're very excited because this is like from 500,000 years ago to 1,000,000 years ago. There's a gap and they have not much at all. And so they have these fossils that are, obviously hominid. And so they're taking a look at that. And the date is like from the methods they've used, they have a really, really confirmed date for the chronology of it, 773,000 years ago. But they also, if they could find more evidence, fossils across the African continent, then maybe we could start putting more pieces together. But this is that issue. It's like there's a puzzle and you never had all the pieces, and you have to go around the world and find all the pieces to this infinitely complex puzzle that you don't have a picture of. So you have to go, and most of your puzzle is empty. That's basically what we have right now. But really, they say that there's probably a last common ancestor. Was it on the Eurasian continent or the African continent? This last common ancestor, they don't even know if it is these fossils, but now they have something that is indicative of potentially being involved in that pathway. And it's still on the African continent. So, question, we don't know if this is the last common ancestor. We don't know.
And we don't know if they're only in Africa or if there are a bunch of other places too.
Right. That is exactly the thing, because it could have been boop, boop, boop all over the place, these little tiny populations evolving for hundreds of thousands of years. And
well, I mean, this is what we were just talking about,
species.
adaptive radiation. So how many different kinds of hominids were there living at the same time on this planet?
We don't know. And genetically, we have only the understanding of the ones that survived long enough to contribute to our ancestry, right? The ones that are, the magic dust in our genomes, or in Neanderthal or Denisovan. There's like, ooh,
Right.
dragon man.
And if it was just a little bit millions of years ago, we don't know.
We don't know. Yeah. But it's exciting because this is new fossils filling a gap in time that they have that they've dated very, very well. And, it adds to that like kind of exciting question of like, ooh, ultimately we all came from the African continent, but it's like, where did the actual Homo sapien lineage with all the traits that make us human actually get its start? We don't know that. Scientists.
I mean, we all came from the ocean if you go far enough back.
Exactly. Maybe we all came from
before that. We all came out of organelles.
RNA. That's what. Other old news. Researchers out of Stanford have looked at arrowheads that they discovered that are 60,000 years old. These old arrowheads were discovered in Latuzana rock shelter in KwaZulu-Natal, South Africa. And they were dated to 60,000 years ago, which, great, okay, 60,000 years ago, arrowheads, hunter-gatherers, awesome. But the exciting aspect of this is that they identified toxins related to certain species of plants that are known to be toxic, and that they are identifying and associating with the use of a poison tip on the arrows. They're suggesting that the population of humans who lived at this location in South Africa were aware of the toxicity of certain plants in the environment, and how they're related to amaryllis, kind of, so like the bulb and other aspects had to be mashed and heated and used very carefully, and they didn't want to actually leave the poison in their houses or their caves. And so there is evidence of a separation of the living location and where these poison-tipped arrows were found. And what they're saying is, oh, geez, 60,000 years ago, humans could plan ahead. They knew they wanted to kill the deer, the whatever deer they were hunting 60,000 years ago. And so 60,000 years ago, they're like, plants are toxic. I'll spike them with a poison arrow and then I'll chase them less far. Yeah. Anyway, 60,000 years ago, people were smart. Duh.
I don't know. You sound kind of skeptical about that. Do you not think that they did it on purpose, or you do think?
I do. I am being the voice, and overacting was because we're aware of Neanderthal behavior going back beyond 60,000 years because of evidence. We're aware of it's just like, oh, okay, they were smart 60,000 years ago, just like us now. They could plan ahead and make hunting tools to go out on hunts and know that they would be useful in certain ways. So
also just knowing what poison is a fundamental part of being an animal. Right. You know to avoid warning colorations. You know to avoid something that your friend ate and barfed. Like you learn about poison from, very what you would consider like not super intelligent animals figure out
possibly poison. Even from birds, right? Wasn't that one story last year?
Yeah, absolutely.
Birds telling humans about poison.
Yeah, and then, there's insects that tell each other. There's plants that warn with
Mhm.
with specific colorations or other things like these guys. So, yeah, did they stumble across it and then decide to use it? Did they know it was poison and seek it out? Did they pass this along from generation to generation? Probably all of those things.
Yep.
Yeah.
Probably because it helped with hunting, with getting food, and with their survival. So, yeah, and we've been sharing information for a very long time with our offspring and training. It's how we have like survived through education. Mhm. Brian Burwell is saying, could the spears just be tipped in toxins because of a mist that landed in the plant? Although that could be how they learned as well. Probably not, because of the way that the toxins were found on the arrows, arrowheads existing on like the ventral edge on the dorsal surface. They have like specific microscopy and work that they've done to identify and locate these toxins on the arrowheads. But I think it's cool that they looked for it and they found it. And ancient people knew about toxins and did arrows covered in poison to kill their prey. And now we're here. So, hey, we have more stories, but I want to say, not me. That's me. Hi, now I'm here. Wait, you're gone. Now I'm here. Here we go. Everything's great.
Do-si-do.
This do-si-do. Thank you for joining us for this episode of TWIS. We are here to talk about science, all our curiosities and our interests. I hope that you're enjoying the show. And we have much more to come. In the meantime, I would like to ask that if you are not yet a supporter of This Week in Science, please head over to TWIS.org and click on the Patreon link. If you're interested in helping us out on a monthly basis, you can help us out at any level. It all helps so that we can continue to bring you this show. Also, the Zazzle store's there. There's really cool stuff there. Blair has a cool piece of art in her background tonight on the show, if you're watching in the video. And it's pieces of art like that that have gone onto many of the items in our Zazzle store. So support Blair's art, support science, support us talking about science, support curiosity, support independent media, and please head to twist.org today. And share with a friend. We really can't do this without you. Thank you for your support. All right, Blair, are you ready? Are you ready
I'm
for
ready.
the next part of the show?
Mm-hmm.
What is the part of the show? I forget. Oh my gosh. Wait, no, now I remember. It's Blair's Animal Corner. With Blair. Wait, what?
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have a story about a 400-year-old shark
Like
with
really?
milky white eyes.
Whoa.
And a parasite on their eyeball.
What?
Who might be able to see. So, turns out Greenland sharks, they are, to date, the vertebrate observed with the longest life in the animal kingdom. They can live hundreds of years. Yeah. There have been individuals estimated to be between 250 and 500 years old. They're one of the largest shark species still on the planet. They're about 21 feet long. They can weigh over 2,000 pounds.
What?
They reach sexual maturity at 150 years old.
Wait, what?
And they give birth to live pups after a gestation period of 8 to 18 months. Also, by the way, they are toxic to mammals. If you tried to eat a Greenland shark, you would not fare well. That's because they have high levels of methylamine nitrous oxide. And so it's because they're in these remote, deep parts of the ocean. They're very strange animals, the Greenland shark. And so I'm pretty excited to get to bring them to you just so that you can learn about them today. But one thing about them is that it has been assumed for a really long time that they are blind. And it's because they have these copepod crustaceans that attach themselves to their eyes. The copepods can bioluminesce, so they're like bright in their eyes. They attract prey for the sharks, so the sharks don't really have to see. Prey just kind of like butts right into their face because of these copepods. And so this is the hypothesis, is that they're blind and that this relationship is mutualistic. So the copepod is like latched onto that eyeball, and in return, they provide food. But the parasites can cause damage to the shark's eyes, and it can cause ulceration, mineralization, edema of the cornea. And so in a lot of cases, the assumption is that they are completely blind. As far as they can tell, though, the loss of vision does not seem to reduce life expectancy or their ability to catch food. So that's interesting. Like, are they just
using lateral
using
line systems,
hearing
sensing?
and
Yeah.
lateral lines and senses of smell or any other sort of sense organs to kind of feel their way through, especially because they're kind of low light animals anyway? Okay, so all that to say, also in 2024, they were able to sequence their genome for the first time ever. Just all background information so you can understand the story. So in this piece of research, Greenland shark eyes were studied. And it's because if you look at videos of the Greenland shark, you see them move their eye. And it looks very deliberate, like they are tracking light. So they can't be blind if they're moving their eyes in response to visual stimuli. So if they're not blind, how do they not degrade their vision over literally hundreds of years?
Right.
How do they maintain vision with crabs on their eyeballs? And why? Why would they put all this effort into maintaining vision if they don't need it? If they're in low light, if they have these crustaceans giving them takeout every night, right? So why is this happening?
But is it like, we get cataracts and you're not completely blind, but you have light or dark. You can see, the things get hazy and you can tell there's somebody there. You just don't know who it is, right? So
yeah, so the current hypothesis based on this study was that there is a DNA repair mechanism that enables the sharks for hundreds of years to maintain their vision with no signs of retinal degradation, and that they continue to be well adapted to low light conditions. When you start to lose your vision, low light is a problem. So the fact that they can still see in low light means there is some sort of repair mechanism at play. And so what they did is they were able to receive frozen Greenland shark eyeballs and then study them closely.
wow.
Yeah. So they were able to dissect preserved eyeballs in a fixative solution. There's a whole funny story in here about how it was smelly. Of course it was. You couldn't let it thaw too much because it had previously been frozen, so it would basically just turn to muck if you let
Ooh,
it thaw all the
yeah.
way. So they had to let it thaw just enough to be able to look at the histology of the eye, what diseases might be in there, how healthy is it, and then also do some vision specific analysis of the eyeball. They found no signs of cell death. They also found that rhodopsin, which is a protein essential for vision in dim light, remained active even while infested with these little crabs, and that they were able to detect blue light. There's not a lot of research on shark vision, so this is kind of a new world. And so this is a really interesting opportunity, especially because they believe there's a DNA piece to this, that there's a DNA repair mechanism, which is allowing them to maintain vision for hundreds of years. This is really big. So first of all, it's an opportunity to study shark vision in general. Second of all, it's an opportunity to study vision in long-lived animals. And third of all, it's an opportunity to take what we learn to potentially help heal vision in humans. So it's a lot of jumps, but I think that there's an opportunity out there.
That's a lot of jumps from Greenland sharks who are sensitive to blue light. So they have rhodopsin. They're not seeing lots of other, but dark. So if you're under the ice, you're in the dark, you're in the cold. If you're going deep underwater, you really don't need tons of color anyway. And blue light would be very specific to underwater. But
yeah, it's a lot of jumps, but
it's a lot of jumps.
Any organism that can repair vision for hundreds of years in their body, like, we're kind of used to eyeballs being like, you get what you get, you don't get upset, you use your your phone too much in the dark, your vision gets worse. You read too many books, your vision gets worse. You spend too much time on the computer.
When you get old, maybe you can use your healthcare insurance to do a corneal, do some kind of eye surgery that, gets rid of your cataracts and makes you healthier.
Yeah.
Gives you young eyes again. But wow, like this is wild. Like, first, Greenland sharks are amazing. And second, this is really interesting. I mean, I don't know if they can study frozen Greenland shark eyeballs and, figure that out. Maybe they can do better for humans. But
you know what Greenland sharks look like to me? They look like a dirty russet potato.
What? Wow.
It's just all I can see.
Now that's what I see. Oh my god.
Do you see it? Good.
It's a pointy russet potato. It's like the one, it's not the big round one, but it's the pointy russet potato. And there's that the eye spot on the potato that you want to cut out.
Oh my gosh. That's like, there's one picture in particular that I think just looks perfect. Let's see. An image in your tab.
How? I mean, do they just exist with cataracts and they're good with it? And that's just how,
maybe.
Like, what do they see? So now what we need to do is get one of those brain computer interfaces for Greenland sharks to see what they see. Like with cats, sharks.
Look, tell me this isn't a potato.
It just it's a potato with a tail.
Yeah.
Wow. All right. Yep.
I want a baked potato now. Oh, goodness gracious.
After show potato time, everybody.
All right. Well, that's all I have, Kiki.
I did see something recently I thought was interesting. So apparently these old metal spikes that we used to have at my parents' when growing up for potatoes, you put them in the oven or whatever, and you spear them with these little spiky things. They were made of aluminum, and it was so that the heat could be transferred from the oven into the inside of the potatoes to help increase
cool.
potato cooking time, the baking time.
Yeah.
But they only reduced that baking time by about 5 or 10 minutes. So when microwaves came about, they fell out of favor. So
Sure.
that's, your day in antiques on This Week in Science.
Well, because it's aluminum, that means you could also probably bare-hand it much sooner straight from the oven, which is pretty
Right.
fun.
Because of the heat transfer properties of aluminum.
That's awesome. That's one of my favorite like magic tricks to do. I'm like, science is to put something on aluminum foil in the oven and then just bare-hand it out of the oven, and people look at you like,
what are you doing? You're like, no, it's fine. The aluminum foil is like, the heat's gone already.
Yeah,
it's warm. It's fine. Well, I have a couple of stories to round out our show related to brains, because I love brains. And I'm going to start with the health of our aging brains, as we were talking earlier about, oh boy, this show is getting on in age, and people, we all are getting older. And we talk a lot about research looking into diseases of the aging brain. So dementia, Alzheimer's disease is another one. And there were a couple of studies out this last week related to Alzheimer's disease that are kind of interesting. So the researchers in a study published in the Proceedings of the National Academy of Sciences, they added on to research that had been done looking at blue light therapy, so light in the 40 hertz range, and how it seemed to moderate or ameliorate certain symptoms of Alzheimer's disease in patients. Research has been done on that. They've seen in several studies that the blue light therapy actually leads to a reduction in the beta amyloids in the brain. And these other researchers started going, well, maybe if it's the 40 hertz stimulation of light, it is related to this gamma oscillation frequency within the brain that is related to the networking and connectivity of different areas of the brain. And so they were like, well, what does it have to be light? Can it be sound? And so a lot of researchers were like, let's try sound. And sound seemed to work, and they saw some evidence. And then there was a study that seemed to go against that, and they were not able to replicate effects of the auditory 40 hertz stimulation in mice. The researchers in this particular study were like, let's just not do mice. Why don't we actually look at animals that are more closely related to humans? And so they did auditory stimulation at 40 hertz of rhesus macaques. And they were aging rhesus macaques. And in the study, they looked at markers of the beta amyloid or amyloid beta metabolism within the cerebrospinal fluid, and also of the tau tangles. So the suggestions from previous research were that as the oscillations occur, as the stimulation occurred, it stimulates the brain, and so cerebrospinal fluid flow increases, and so you get more kind of flushing of the bad things out of the brain. So it kind of stimulates the brain into activation that hasn't been activated before. And by doing that, you get flow. And so the cerebrospinal fluid is kind of like it's moving stuff out. And so they suggest that by looking in the cerebrospinal fluid for the amyloid beta and tau markers, that is a marker of the change in metabolism of these deleterious molecules, that they're being flushed instead of actually staying in the cells. And so that's what they found. So with their groups that had 7 days of continuous 40 hertz auditory stimulation, that's a lot. That's a lot.
Drive you insane. You're just like music though, or
just 40 hertz just 40 hertz.
Just like,
Sound, whatever 40 hertz sounds like. Yes.
Yikes. No,
Continuous.
thank you.
Then they had random stimulation, and they also had stimulation that was not 40 hertz. So to control for it, and they randomized when different monkeys got different stimulation to control for possible sequential effects. But what they found is that with these animals, they had increases in these markers in their cerebrospinal fluid. And at the end, when they looked at preserved brains, they were able to show that there were decreases within the experimental group in these markers within the brain.
Hmm.
So it's not in humans. It's not saying, yeah, this absolutely works. And it's not something that is, doesn't get rid of it completely. But what they found is that it was an effect that was maintained over time. So when they had the stimulation for several days, after that, up to 49 days, they had a consistent improvement in these markers in the animals. So, of course, there's more work to be done. This is a small group of animals. There's so many questions, but what they are suggesting is that this is evidence of the ability of stimulation at this quote unquote gamma oscillation frequency, which networks and like ties together multiple areas of the brain. So kind of like your kind of basic brain network, and keeps them connected. That by doing that, it might keep things working a bit better.
So
And
how do we know that it was the sound stimulation and not the fact that they were hearing a constant hum that kind of like stressed them out and made them think extra hard and just kind of like made them,
because they had
exercise
randomization.
their brain?
Yeah, they had randomization of different groups. So some groups got nothing, other groups got the sound at the same time. And then they had a switch to who heard what when.
Right, but I'm saying like I'd want 60 hertz and 20 hertz and 100 hertz so that I
Mhm.
could say it is this specific sound stimulation and not just basically annoying these monkeys with sound that is doing it.
Right. And so that's why they had a control group that had no simulation, and they had different variations on the groups.
Okay.
Yeah. But anyway, yeah, there is still a lot in, and you're right. There is a lot in question here. This is all kind of based on this previous research that has shown that 40 hertz seems to work really well.
Yeah. I also think, in humans, this is a tough one because if it's quiet enough, maybe it's not such a big deal. But to somebody, well, I guess this is a prevention, right? It's not a treatment. Or there was plaques in the
So-
brain, right?
Yeah, so these are older monkeys. Yeah. So this is one of the questions, right? And where they have used this already in human trials has been people who have Alzheimer's disease, and they've seen benefits, and they've seen improvement in their behaviors, in their behavioral scores.
Yeah, how are their behavior scores while it's happening though? See, that's the part that I'm questioning, is that a human with Alzheimer's,
yes,
it is difficult to explain to them, hey, I'm going to play this sound. It's going to be annoying. It's going to help you, right? So I think that's the part that also is difficult, is doing something that at its core, I don't know, maybe I'm blowing this out of proportion, but it feels like it'd be annoying to hear one frequency of sound for hours. Seems like that would drive me insane.
And this is the question, right? So, okay, they did that with the monkeys, right? How could this work in people?
Right.
Would it work in people? Could it be that you have your meditation period for 20 minutes once a
Or
day?
do you have a particular prescription CD that has music on it that has a low-lying background of 40 hertz or something, right?
And would that
Like,
work?
is there a way you could just like, I'm just gonna listen to my prescription CD for 45 minutes and then I'll be good. Like, I think that's the part that's harder for me, is thinking about just putting on the for somebody, for a human, for hours.
And so this is the interesting question, though. In Alzheimer's disease research, what they're trying to do is find alternative methods for prevention and treatment. And this is more like once you've already been diagnosed, maybe this will help keep it from getting worse. But with medications, there are all sorts of side effects that are awful. But because Alzheimer's disease is worse, people put up with it. And so I think it's great that they're looking at all sorts of weird, different ideas. And if there is something as simple as finding a way to stimulate the brain in a way that people can handle, like we should go down that avenue, right? And if it's something you can do at home without electrodes, which is something, that people can do easily because, we listen to music, we do whatever,
or even better, find a hertz that we can't hear that still stimulates the brain, and wear hearing aids that also play that at the same time directly into your ears.
Right. So this is the interesting question is, so because we've talked about Alzheimer's disease and other diseases of brain aging as potentially being metabolic issues related to astrocytes and mitochondria and other issues that are actually kind of before the amyloid beta tau protein accumulation, like it's interesting to have the question of, kind of the going back to the basics of neuroscience. There's use it or lose it, right? Is one of the mottos of neuroscience, where is there something to the deterioration of the brain's ability to have that network connection that it needs for rest and for repair? And is there something to a particular frequency or wavelength? Or are there multiples? Are there harmonics? Are there other aspects to it that can be also employed? We don't know any of this yet. This stuff is just so weird, because it's we know this works kind of, and it helps people. And it's so odd. So
it's really weird. Yeah.
But I would
if somebody told me to go take a sound bath for my brain health, I'd tell them to go count their crystals. But this is something that might actually be real.
Yes, exactly. Yeah. So why? I think there's so much that we need to dive into here, and I'm fascinated to learn more as it all grows. There was another study also where this is crazy. Case Western Reserve University Hospitals in the Cleveland VA gave a bunch of mice. This is in Cell Reports Medicine. This is not humans, but they also looked at human tissue as well. It's published in the Proceedings of the National Academy of Sciences. They used a pharmacologic agent that is not available for purchase as a supplement. It has not been approved for humans. It's called P7C3A20, developed by the laboratory that published online in Cell Reports Medicine. Their results, by applying this particular agent to the mice, it impacted the nicotinic and adenoside NAD plus levels in not just the body, but the brain. And they were able to protect mice from developing all of the indications of Alzheimer's disease, and also delayed treatment in mice that had advanced disease already, enabling the mice of the brains to fix things that had already happened, damage that had already occurred due to the errors within their brain. So NAD plus has been identified, NAD plus has been identified as a wonderful kind of like anti-aging molecule. But one of the issues is that in animal models, it has been shown to actually lead to cancer promotion, which is not great. And so they're trying to find different agents that impact different parts of the pathway. A lot of people are like, take niacin, do this, do that. But because of the way that the molecules work and where things end up, they're trying to find more direct treatments, direct molecules that could target actual damage within the brain. And so what they are looking at is seeing whether or not they can take this efficacy that has been seen in animal models and translate it to humans. And that's the next place that they're going to be going. But basically, what they are seeing is something that sounds amazing. It's that by improving the NAD plus metabolism with the brain, it basically allows and NAD plus decreases as we age across the body. And so by improving it, increasing it, it maintains a lot of the metabolic functions that deteriorate as we get older. So this is very interesting, still in animals, but again, could it be something that's like a supplement that we could take? Could it be something that's, easier to manage, easier to take?
Will the current administration support this research? Will the current administration allow these things to be sold?
I don't know. I don't know anything about that kind of stuff. I'm just excited about this, this progress. And we know that so many things that work in mice do not work in humans, but this is basic metabolic pathways. And we know that there are benefits. People have found benefits to NAD plus supplementation in their lives, but not everybody. So there's still a lot to be, parsed. Final study, though, if we want to know what it is that makes our brains so awesome, this recent study, it blows my mind. Proceedings of National Academy of Sciences researchers at Northwestern University have built upon previous findings of their lab, but basically they gave small and large primate bacteria to mice that had been raised without any bacteria to see how it impacted their brain function, so the metabolism of their brains.
Okay.
And we know that there are certain metabolic signatures for humans, for primates, large-brained primates, for humans that have autism spectrum disorders, for humans that have schizophrenia, for other disorders. They found with these mice that the mice who were given the large mammal bacteria or large primate bacteria, that these are rhesus macaque bacteria.
Yes.
That the metabolites and the genetic markers that they found in the mice was basically like human or like the rhesus macaque metabolic markers. So they went from regular mouse metabolic markers of neuron activity, I'm a mouse, I do mouse things, into the kind of activity that we find in a much higher cognitive function organism. And they found that the small primate bacteria, which were, I think, from squirrel monkeys, they found that the genetic markers and metabolites were similar to what is found in individuals with autism.
Really?
So, yes, and these were mice that had they're developing and had their own. They didn't have any bacteria. They were germ-free mice, right? So they had none of their own bacteria. But then when they were given these different like bacteria baths, it impacted the way the activity, the strength of the activity, the synaptic plasticity that the neurons had. So the amount of synaptic plasticity that we are so excited and, like, we're like, we're so great. We have so much synaptic plasticity. Thank your bacteria. That's basically what this study
Of course.
is saying.
We're just the city bus for the bacteria. They're just trying to keep our oil changed and our transmission checked. And
Yep. So these mice they're not human, they're not monkey, they're not thinking that way, but the bacteria accentuated their neural activity in a way that was very similar, so kind of parallel to what we find in these particular groups of primates. So it's not just genes, it's also your bacteria influencing hormones and proteins and all sorts of other things and also the bacteria themselves influencing how the brain works.
Wild.
Yep. All right. Thank you, bacteria. I'm going to make sure to keep licking all the bus.
Kiki, don't.
No, I'm kidding. Lick the shopping carts. I'm going to be human, darn it. No.
My 2-year-old has entered the licking phase. It's very gross.
I do not recommend it. Do not lick things. So hard. I'm
just going to be sick for the next 4 years.
14. I don't know.
We'll see.
Yeah. Anyway, this has been our 2026 inaugural show. Thank you, everyone, for joining us for this wonderful investigation of science. I hope that you have enjoyed the show. Everyone, it's time for some shout outs. Thank you, Fada, for all of your help, especially over the break in prodding me. And I'm sorry again for not being in working condition. Everyone, thank you for being here tonight. And I hope that you will be with us as we produce more shows throughout the year. Gord, Arenlor, others, all of you in the chat room, thank you for keeping it a safe and happy place, compassionate and kind and respectful. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. And I would like to thank our Patreon sponsors. Thank you to Aaron Anathema, Adam Mishkan, Alan Viola, Ali Coffin, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshak, Dave Wilkinson, David A. Youngblood, Don Mundus, Don Skiles, a.k.a. Don Stylo, E.O., Eden Mundell, Eric Knapp, Flying Out, Fred S104, G. Burton Lattimore, George Corris, Greg Briggs, Jack Jason Olds, John Atwood, John McKee, John Ratmaswamy, Johnny Gridley, Ken Hayes, Kent Northcote, Kevin Parachan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hessenflow, Mark Jenkins, Noodles, Packard Pecoraro, Paul Disney, Paul Ronovich, Philip Shane, Pierre Velazar, Richard Badge, Robert Norland, Robert W. Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence Lamb, Shubru, Stephen Albaran, Steve Leisman, A.K.Z. Masood, Oster, Teresa Smith, Tony Steele, and Vegard Shefstad. Thank you. Thank you so much for all of your support of TWIS and your support on Patreon. And if you are wanting to support TWIS on Patreon, head to twis.org and click on the Patreon link. On next week's show,
We'll be back on Wednesday at 8 p.m. Pacific time, broadcasting live from our Twitch, YouTube, and Facebook channels.
and if you want to listen to us as a podcast, just search for This Week in Science wherever podcasts are found. Make sure you get a friend to subscribe to.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twis.org. You can also sign up for our newsletter.
And we do love your feedback. If there's a topic you would like us to cover or address or a suggestion for an interview, please let us know on one of our social media accounts or send us an email. Make sure to put TWIS in the subject line so your email doesn't get spam filtered into the muscles or eyeball of a Greenland shark, because nobody's going to eat that.
Not for 400 years.
No.
We look forward to discussing science with you again next week. If you've learned anything from the show, remember,
It's all in your head. I did the wrong song.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news that what I say may not represent your...
Science, 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 science.
science, 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 science.
Thank you for joining us. This is the after show, but we are tired. And I apologize for not being up for a big, long after show to everybody. I don't have the energy right now.
I cannot.
I cannot. Blair, you and I need to discuss at some point whether we're gonna do any of the fun end of year show, like the prediction show, the top 11 show. I'd love to, but it feels weird to do it without Justin.
Yeah.
So I'm a little bit like, but yeah. So there will be a show next week. Blair and I need to talk about what we want to do,
What
how
it
we wanna
is.
do it, what it is, what it is, what it was, what it will be,
What it isn't.
what it isn't. Yes. And I apologize for that. It just feels like those, as much as I love those episodes, there would be missing something if it were just the two of us.
Mhm.
So, and I don't know everyone out there how you feel about that, but that's kind of how I feel. So if we can maybe figure out how to do one on like one of the days that Justin is not working.
Is that ever the case?
No. Yeah.
We'll figure it out.
Yeah.
We'll coordinate and we'll do it.
Yeah. But anyway, thanks, Blair. Good show. That was fun. Thanks
I had
for
a great time. I'm just
midnight
crashing really
nautilus
fast.
knowledge. I know. No, I'm hitting. It's time to go. Take care of ourselves, everyone. Say goodnight, Blair.
Good night, Blair. Say good night, Kiki.
Good night, Kiki. Good night, everyone. Thank you for joining us. Back to the year, back to life, back to reality. And I do hope everyone stays safe. Be safe. Protect your neighbors. Speak truth to power. Bring lies to the surface so that they are seen as lies. Support the truth and be curious. And be lucky.
And vaccinate your kids.
That's right. We'll see you next week. Good night.